Cool. Okay. So we'll talk about data protection because that's what we've just announced. And the data protection platform, it's important to note that it incorporates a lot of what we've done already. So it's a platform that incorporates the movement of data. It incorporates the management of latency with the use of non-volatile memory. And it incorporates an I/O filter as the mechanism for data intercept. So I think you've probably already heard enough about the merits of using an I/O filter for data intercept, but we have an I/O filter obviously in the hypervisor, and again, we can run on top of your traditional shared storage environment or an HCI or virtual SAN environment. Now, the idea, however, in a nutshell for data protection is here, the crash-consistent data pipe. It's a multi-channel communications capability between the on-premises environment and the cloud. And the idea is that with the same infrastructure here in the on-premises environment, we can provide data protection capabilities that would range from a full failover location for DR, a full failover location for business continuity, a data recovery destination, which could be an object store or an NFS store, or it could be a VMware environment, and a continuous data protection capability with point-in-time recovery. So with these three objectives, we want to provide an infrastructure to the on-premises environment that it can use a policy engine to define availability groups or recovery groups that have the same policies for data replication and for recovery. So in some cases, we're setting this up with replication to a VMware environment in the cloud with the understanding that if we have an incident on premises, we want to be able to fail over and spin up in the cloud destination in a matter of seconds. In others, we're replicating data simply for the purpose of backup to something more economical. Okay? Now, the architecture itself is based really on this multi-threaded, this multi-channel communications pipe between the data center and the cloud service. However, we can optimize the latency using flash, okay? Using non-volatile memory appliances for the replication log and for an acceleration buffer in the cloud. In doing that, we now have both a very thick pipe and a very fast pipe between what's going on here and what's being replicated here.
Can you dig more into that crash-consistent data pipe?
Sure.
What's actually going on the back end there?
Why don't you take over?
Okay. Let me tell you how it actually works. VM issue IO, we intercept it here, and after that we write it into low latency replication log. And on top of this, it is a software module that we call logger, and this logger inserts into metadata, so data and metadata. It inserts into metadata sequence number. This sequence number is across all virtual machines and all virtual disks that belongs to recovery group. Because of that, for example, we can provide protection for Oracle RAC, for example, which is not trivial at all because, you see, virtualized Oracle RAC, it writes like this, but how to provide sequencing writes, what is overlapped writes. So this guy serializes everything because of this replication log and assigns sequence number. Data and metadata transferred here, and again, there is a mix of data, even a sequence number 1, 2, 3, 4, 5. Actually, on this side, it could be 4, 3, 1, 5, whatever, because we do not want to serialize it here. But when we receive it here, we have sequence number that tells receiver VM, which is actually a Linux appliance, what's the order of, what fidelity of writes, what order IOs were completed, because we cannot change the order of this. When we receive data here, we immediately dump it into this, pretty much immediately, dump it in this acceleration tier. Why we do this? Rich mentioned this, but it's very important. If we have high latency here, because of promised RPO, you propagate this latency over here, and actually you slow down application. So from the day one, and actually you can see in this product, everything what we developed in the past, it is here. Our caching, which is replication log, but actually it is caching. And later we, of course, flush it here. That's how we provide some consistency. Crash consistency, actually, it is a software here and software here. And at any moment, we know we have crash consistency over there. So because of that, at this gun, we know 1, 2, 3, 5 cut here, 1, 2, 3. That's what we start business continuity on that side. Maybe a couple words, because probably, I don't know what, maybe a little bit about CDP. Actually, CDP has a use in two ways, I would say. One is, yes, we replicate continuously, and it's a continuous protection, because it's not a snapshot based, it's not a discrete. It's a big difference between backup and DR, actually. Yes, and we have very limited, I would say zero RPO pretty much. On the point where we are, we immediately start, we fell over from the point where we have consistency in a destination. But it is very important when your on-premise data center is down totally, and after that you recover everything. What if it is data corruption, virus attack? How to move forward, or how to move backward in a time? And CDP also helps you to roll back and forward multiple times, because we do not know for sure where it happened. So let's say it happened here, but after that you want to move here, not enough, here, okay, but maybe it's too much, maybe here. And you don't want, like in a backup, to restore the full backup, apply incremental backup. No, you want to do it like this, very, very quick. Not in a seconds, because anyway, this is not, it happened not every day. But it should be fast enough, not a day, not in hours, so very fast. For example, we can pretty much instantaneously to roll back 10, 20 minutes backward. So basically here we have actually redo and undo log. And because of that, you have image of virtual disk here. We create snapshot, and after that, link clone, and we replicate from the cloud backward data to move your image of your disk backward in a specific point in time. If it's too far, you can move forward, really backward. And we do not, as I said, we do not require to create full copy of virtual disk here, because it will be forever. I would say this design is very interesting, I would say, and we have lots of interest, especially for HCI vendors to object store. You know that in object store you cannot overwrite object. It should be new object. It's like this. Let me use S3 API terminology, but actually you will see that it works for any object store. What we do, we really, same as here, we first make an initial copy. By the way, initial copy is our migration product, because migration product, when you migrate, you do not have consistency on a destination. It is okay, but after that we smoothly switch to consistent replication. So we, as same as here, we create initial copy, and after that we start replicating data and writing it in objects one by one. So simple, right? Actually not. If you overwrite many times same data, you allocate here just unlimited amount of storage, and we have to provide some kind of garbage collection. if you're familiar with SSD terminology, write affinity and garbage collection, there is a lot of similarity between managing this write affinity garbage collection in SSD and here. And we provide and write affinity and garbage collection. Write affinity means the following. It's related to, are you familiar with write affinity? Yes, no? You see the problem here, right? You overwrite same data again and again, and some of your objects has a lot of garbage. So it means that you overpay to cloud, and your amount of your data will grow unlimited. But if the same data is overwritten multiple times, it is a hole in this object, and a hole in this object, and a hole again in this object, and in this object. So actually, your storage in the cloud is over-provisioned. In order to avoid this over-provisioning, you should take object with a lot of garbage and compress it, and write in a different object. And this is delete. So that's how your storage in the cloud will be like this. Upon demand, and it's really upon demand. We need extra storage here, write a new object. That's it. But this garbage collection is not simple at all. And this is a key of, let's say, firmware that write in SSD. And write affinity means the following. If you have hot data and cold data never changed. Hot data is changed. So it means that if it is a hot data, wait a little bit, because it will be overwritten by itself. And where you provide garbage collection will be just few valid data here. Cold data is really very stable. It's written and sitting forever. So write affinity is a definition, how to define actively modified, frequently modified data, and selected from infrequently modified data that helps for garbage collection. So this is very, I would say, very elegant design. For example, for garbage collection, again, why I'm talking about garbage collection? Because it's a foundation. It's a basis for any storing DR in an object store. So garbage collection is a complicated part here, and we never read, by the way, we never read from the cloud. We only push. It's only writing into the cloud, which is cheaper. So all garbage collection, for garbage collection, we don't need to read these objects from here. Yes?
Can I ask some general questions about orchestration? You've got disaster recovery, business continuity.
Sure.
How do you test that you can actually do there? Is there a test button that you can press to bring up the VMs in the cloud?
Basically, the mandatory part of, if I understood your question correctly, mandatory part of DR is testing of destination environment. So basically what we do, same as everybody, kind of everybody, not so many DR products in the market, by the way. We stop replicating, for example, for simplicity. Actually not, but we stop replicating. We create for each virtual disk and destination, we create snapshots for all VMs. We create snapshots. Actually, we create snapshots for receiver VM. Excuse me. We create snapshot for receiver VM. As a result, you will see snapshots for all virtual disks in a destination. After that, we power off receiver VM, detach virtual disk, and attach to virtual machines that we bring up, like in case of failover. We bring up these virtual machines, attach in clones, and let system administrator run it. Right. If everything is okay, it is okay. It's normal. In this case, we use native snapshots, but in a destination only in case of testing destination environment.
And that testing process and the failover itself, can it do things like re-IP a virtual machine, run scripts between each virtual machine, that kind of thing?
It's a very good question. So we are responsible actually for replicating data and updated configuration for virtual machines. We do not do, at least at this moment, anything with networking. And networking should be predefined. Before final migration, network should be predefined.
So if I had an IP range of 10 whatever in one location, and it was a different IP range in my DR location, it's up to me to do the re-IP process.
Typically, it's a system administrator in a cloud responsibility to provide virtual private cloud, and it's up to him. It's possible.
Quite a lot of work to do, though, isn't it?
It is a lot of work, but to migrate data is also a lot of work.
Yeah, I mean, when you talk about RPOs and RTOs, it isn't just the replication of the data, it's the entire process of bringing up that service. So it doesn't really matter to me if the entire process takes this length of time, if the part that actually ends up delaying it is
you're right.
Charge of.
I would not say about RPO, because RPO is recovery point objective, and it's unrelated to how much time we have to spend to start some scripts in a destination. It's about RTO. RTO, yes, it takes time. For example, we do not require and this is scriptable really, to have, if I have here 16 servers, we do not want to require 16 servers in a destination. It's just couple. For high availability, it's couple.
Right.
But if you want really, if you're talking about some failover, you have to populate all servers as you need.
Right. Okay. And
yes, it takes time, but it is SDK to all target clouds, and it is scripted.
And then the final, there's three parts to this question. One about
go ahead.
Testing. What about other orchestration? What about the failback process? When I need to return my VMs back to my data center, what orchestration do you have for the failback process? Because failover is actually easier than failback.
Oh, really? I
think so.
I think failback is easier because this is our migration product that we told you about. We have two types of recovery on-prem. Full recovery. If you have to rebuild your storage from the scratch, it is migration product that we told you about. It's exactly like this. You run VMs here, and at the same time you replicate it here. It's exactly what you have. Not that you smoothly switch from here to here and continue using, obviously.
Yeah, perhaps I should explain why I think it's harder. Okay. When you do a failover, you've had a disaster, you have no choice but to do it. But when you do a failback, it's a business decision about whether you're going to do that process. And it's actually more risk, because if you call the failback and it goes wrong, you've actually created the disaster yourself rather than it being inflicted on you.
It's a good point.
So that's why I see failback as being more risky. It's not just a pure technology decision. It's a business decision to say that we're going to go back. And whoever calls that, if it goes wrong, your head is on the block. At least if there's been a disaster, it's not your fault. So I guess I'm looking at it from another perspective, which is not just pure technology.
I see what you mean. But you see, let's look at this from the different angles.
So is it simply a case of inverting the replication path to
there is a two direction? Let me tell you. Actually, it's a full full failover and fast, what we call failover. First of all, as about single point of failure. In case of failover, we assume that this environment, cloud environment, is redundant, and there is some level of protection there. Failback is kind of, maybe I'll just argue a little bit what you said.
That's okay.
Yeah. Maybe it's not so dangerous, because your virtual machines are running here. What's very important to fail back, but do not start over. You must continue using the same virtual disk. How we do this? We stop this virtual machine whenever all data is here and start it here. And after that, we create receiver VM automatically, attach all virtual disk which is absolutely actual. That is, you don't need, because this VM continues using exactly the same virtual disk that was a target for replication. It's exactly up to date, this disk, and only what we do, attach IO filters, and start over.
Right.
So I don't see really why it is dangerous.
The other question I have about this receiver VM, it's a single VM that has many, many disks attached to it, is that right?
Okay, you have recovery group, you have special sections, what we call part of this replication log, dedicated to this recovery group. Recovery group, as we mentioned, consists of multiple virtual machines.
With
or correct, whatever,
disks, yeah.
HP's, SAP HANA, whatever, because it's very important to support multiple VMs, which are
to keep them
coordinated,
yeah.
in sync. So we have recovery group, part of this replication, individual replication log, individual receiver VM per recovery group.
All right, so if you have 10 recovery groups, you have 10 receiver VMs.
And that's absolutely fine because it's very lightweight. Receiver VM does have pretty much nothing. It's not your production VM, it is receiver VM.
It's just to take the IO.
It's a Linux
changes, yeah.
virtual appliance which doesn't have anything, just got it and write it here.
Right.
What is very important, sorry, I just jumped back and forth. This piece is very important. I mentioned already, sorry, did I answer your question? Because
yes,
I don't want,
fine,
okay.
yeah.
Okay. Thank you for your question,
You're
by the way. The more questions, the better. We have, this is basically, it could be virtual disk with low latency. It is very important to have this piece low latency, very, very, very important. Because you dump writes here, you must dump data in a persistent storage here as well, as soon as possible. Otherwise, this latency will propagate it to this side. And what do we run here because this is acceleration tier, it is write back caching. In our product it's an acceleration product, specific acceleration for Linux, bare metal, runs in a virtual appliance, or if it is external SSD, runs here, and we have write back caching in the cloud. Why it is important? As I mentioned, dump here as fast as possible, but also we accelerate storage in the cloud because we have write back. Because you see, that's what's going on. This cloud handles multiple clients, and writes are extremely important in this case. Write latency and bandwidth is extremely important. And our caching software, it runs thousands copies. We have very good write-back caching. So basically, you can see in this product, we have everything that we bring together into DR.
So one last question, going back to that one about the orchestration.
Yes, please.
The IP and running scripts and checking whether services have been started. Do you have any plans to add that kind of orchestration, or is it always going to be the administrator's job to do that kind of work?
Yes, we do. But in this case, personally, I prefer to have a partner, and that's several companies already identify in the floor in this show that could be a very good partner here. Because you see, if you have NSX here and completely different networking over there, you have to map it somehow.
That's what the solutions do. They do mappings.
So we're in this moment, we're responsible for data migration, as I said, fell over, fell back, continuous data protection, everything what we can do with data and virtual machine configuration. As about networking, there is several offering in the market. And you know, software-defined storage and software-defined network, it's a different beast. So I'd like to find a partner for this and provide this solution.
I don't think anybody's expecting you to know that much about the network at the destination, just to merely map two network labels together, which is the way SRM does it. It does it by label, mapping the port groups of one location to another. And then a re-IPI engine is about sending some sort of information, maybe to VMware tools, per operating system basis to then change the IP address. I don't know, am I making too much out of this?
Again, you're absolutely right. There is a,
As someone who actually has to perform the DR failover, no, not at all.
Are you using a stretch network between the two sites?
No, we're not.
you know,
But you're absolutely right, Michelle, that the idea of orchestration is key. I think we could have avoided most of the conversation if we had been told you're seeking the right partner to do that orchestration layer for you. Because it's not there.
Yes.
As it stands, it's not there. And you're right, it is a
yes,
challenge.
and I agree with your comments, by the way. Again, if it is independent virtual machine and you need only Active Directory on the destination, it's already there. It will work pretty much immediately. If you have complicated networking on this side and you want to replicate this complicated and map this complicated networking to the destination, it is another side of this.
Yeah, I mean, I completely accept what your position is, but I'm looking at it from a customer's perspective. And what the customer wants is a solution to their problem. And what they may not be less enamored by is the idea that we go so far and then it's then your responsibility to work with a partner, or it's your responsibility to deal with the rest of this particular part of the orchestration process. At the end of the day, I've got a DR problem. I want to fail over my application. It feels like the problem is being given over to the customer to deal with. That's from my and there are a number of DR solutions out there that will do that kind of orchestration, and they're available on the market right now. So if I was bringing this to one of my customers, it would be doing a like-to-like comparison and spotting gaps. I could see your point of view, but I also see the customer's point of view as well.
And vice versa, I see your point perfectly. But again, data replication, CDP and all that stuff, it's as it is, it's a huge problem. How not to degrade performance here, how to have crash consistency here, how to support multi-VM recovery group, it's a lot of problems here. CDP, it's a lot of problems here. How to manage it, you are absolutely right. And that's why typically, even migration require professional services. If you look at Zerta, they charge a lot just to set up DR. And a part of setting this DR is actually preparing your destination environment. By the way, this destination environment is a way to check that networking is working properly over there, part of this. We just provide the ability, create snapshot, link clone, continue after that DR. We provide everything for data. But yes, of course, part of my migration and DR fell over networking.
Okay.